Hello everyone, welcome once again to another Power BI related tutorial by Team SlideScope. In this part you will learn how to create a water pollution and disease related exploratory data analysis dashboard. And in this case we are considering all the cases related to typhoid. So in the data set we have information of various factors and number of cases of various type of diseases, and on the basis of that we will try to create this interactive dashboard where you can see average percentage of population with access to clean water, average of bacteria count, what is the meaning of these units, what is the average range we will discuss in the project, then average of contaminant level in parts per million, average of dissolved oxygen, average of dissolved, so we have different parameter. Let me correct this. This is basically average of lead concentration. Then we have filters like country filter, we have region filter, we have year based filter if you want to see data of a particular year. Then we also have the water source type, like, well, it can be a lake, a river, a pond. We can select multiple values by pressing control or command key. Then we have information of sum of typhoid cases per 100,000 people by rainfall, by water source, by country, and you will also see how to create these different groups from the numerical variables that we have, and on the basis of those groups how to use them as a distribution plot, how to use them as a histogram plot. All of this will be covered in this tutorial, so let's get started with it. So the data set that we are going to use in this project is this water pollution disease data set. It's a CSV file that you can download from this particular Kaggle URL. And as per the data set, this data set explores the relationship between water pollution and prevalence of waterborne diseases worldwide. It covers key factors such as contaminant level, access to clean water, bacterial presence, water treatment methods, etc., and can be used for different type of cases like public health research, environmental studies, policy making, and also for machine learning models to predict disease outbreaks based on water quality. And it has a span of 26 years and features 3000 unique records representing various water sources and pollution conditions. So as per this data set we will try to explore this data and try to see the relationship between different features here. Here we have some categorical values like country, region, we have year, we have categorical values like water source type, water treatment method. Then we also have fields like contamination level and pH level, turbidity in NTU, dissolved oxygen, nitrate level, etc. So as per the definition and information given here in this Kaggle URL, I will leave the link of this Kaggle URL in the description. So we have around 24 such columns. So now let's get started with analyzing this data. Now we will open Power BI, and in Power BI desktop we will simply load this water pollution diseases CSV file to get started. Simply click on get data, click on text CSV and connect the dataset. After selecting the CSV file, make sure all your all your headers are properly aligned with their values. If this is the case, you can now load the data. Now the data set is loaded here. First thing that we are trying to do, or first thing that we usually do, is click on the text box and create some heading for your dashboard. So first we will create the heading, and this is from here we will simply do some public health research or environmental studies. So I will just name it as water pollution and disease analysis. Exploratory analysis. But if you are doing it for a certain kind of project, you can rename it as per your desired result. And here we will use font size around 28, and we can choose some color here. Theme and color, etc. We will deal with these kind of things later as well. And here we will simply, first of all, let's collapse the filter, go to effect and enable shadow and visible border for our heading, and I will select the same color as font color as the border color. So this is our heading. Now let's try to analyze. Now in the data set you can see we do have a lot of columns here, like country, region, year, etc. are given, and here we have different other type of values like sanitation. Now since the name of this data set is waterborne diseases, right, water pollution and diseases, we are trying to see the relationship between different water pollution chemicals or water pollution factors and diseases. So here you have information like diarrhea cases per 100,000 people, cholera cases, typhoid cases. So, and we have infant mortality rate, etc. So let's say this time we are trying to analyze typhoid cases. So we can try to create, you know, different type of dashboards. So we can create one for typhoid, one for cholera, one for diarrhea. So first let's see for typhoid. So we will go with typhoid, water pollution and disease exploratory analysis for, or we can say typhoid cases dashboard. And this time I will simply reduce the size. Although the title is long, but I will think something better. But this will be my title here. And since we are keeping this variable or this field as an output, so we will try to see effect of different other fields on this particular case, and here we will rename it as typhoid cases dashboard. So this will be our typhoid cases dashboard. And now let's see the effect. First of all, we have country, region, year here. So first of all, we will create a simple line chart here, and in the line chart what we are going to do, we will try to see year wise whether there is an increment in the cases, or the cases have gone down. So I will keep it here, this line chart. This area I will use for KPI, which I will just show how to create. So first of all, year is something that we will keep on x-axis. When you are creating line chart, so you put something like year or something that is, set something that represents time on the x-axis, and on y-axis you put a numeric value. So we will see typhoid cases. So typhoid cases I will drag on y-axis, and here the measure that I am going to use is sum of typhoid cases. So this will be sum of typhoid cases per 100,000 people per year. And you can see in the year 2009 there were most number of cases were in 2009. We can also use area chart here just to give it a different kind of feel. So this is our sum of typhoid cases per 100,000 people per year, and here we can go in general tab and title is given. So we will simply write typhoid cases per year, and we will make it bold, make the title bold, align it in center. You can also choose a different type of font color here. We can also go to effects, where we can enable shadow and visual border, and we can do the same kind of border as we selected earlier. So this is typhoid cases per year, and we can see as per the given example it is mostly in 2009, and these values are somewhere between 2018 or 14. Now since we have this information, we can also uh, now we can try to create different type of filters like water source type, contaminant level, year, region, country, etc. So for that we will use this particular area for filters. So here we will add a slicer, and in the slicer first we will reduce its width and height because we may need to put many slices. First thing that we are going to bring is country. We will go to format your visual slicer setting and show it as a drop down list, and as a drop down list you can see we have all the countries here. For example, if we select a particular country, let's say Bangladesh, so you will be able to see typhoid cases per 100,000 people by year in Bangladesh, right? In Brazil you can see most number of cases were in 2022. So if you are trying to create machine learning models and you are trying to see which features will affect your output and which will not, so here you can see country wise and year wise there is difference, so both of them are very important. For example, in India you can see most number of cases were in 2009, and since then we can see a decline in trend. So this is something that you can see per country that is given here. We can select our heading here and click on format painter and apply it here. So let's try one more time so that we have the border here, and this is slicer header. We can make it bold. We can select a particular color for it, and now we can create a copy. In the copy we have different fields, so we can select other categorical fields such as region. Region is, you can see, central, east, north. So let's say we want to see cases in central India. So in case of central India, you can see in which year most number of cases were there, what is the total value. And here if you want to show these values, so you can click on it, although it may be too much information on the chart, but you can enable the data labels. So this way you can see that value here, like for example east, north, you can see, right, in which region when there were more number of cases. Remember, whatever we are doing is as per the data set that is given here. So from wherever they have collected the information, we are doing analysis as per this data set. But if you get the same information from more reliable sources, then this will be the way to go. Like you will understand what type of fields to collect, what type of, what will be the procedure to analyze the entire thing. Now what we can do, we can try to create some KPIs. First KPI we can bring is access to clean water, that is percentage of population. What percentage of population has access to clean water, which is given here. So it's given as percentage. So to create a KPI, first we will create a simple card here, and we will bring access to this, and here you will actually see a very big number because the function, aggregate function that is applied here is sum, but we will not apply sum, we will apply it later. First we will reduce the size. There you can see 18.98k access to clean water. So here we will select average as our visual, average as our measure. So you can see average of access to clean water because it is given like this. So if you go to access to clean water percentage, so in some cases you can see it is 89.54% has access to clean water. So overall, how many people on an average have access to clean water, right? So if I have kept the title as average percentage of population with access to clean water, so you can see this time it is not visible. If we'll increase its width, then it will be visible. So if I still want to show it as a card, what I can do, I can go to, first of all, I will hide the label, and in general I will enable the title, and here I will write the text. So although here I will have 2 or 3 lines, but at least this way I can put more cards here. So first thing that I'm going to use is make bold color, title like this, align in center, and I will, although I can copy the same styling, but I will enable shadow and visual border and this color here. So this is average percentage of population with access to clean water. Now you can see on an average 65.45% of people have access to clean water, and in India, if we clear, the overall average is 64.61. You can also see in Brazil, China, Ethiopia, India, Indonesia, Mexico. So for every country, you can see whether the value is more than the average or less than the average. Okay. You can also select a particular region and see in which region it is more. So this way you will be able to analyze which region in which country has better clean water facility, and obviously it is given that this type of data can be used for policy making, etc. Right? So it is very important here. Now we also have bacteria count. So here you can see we have information of bacteria count. So let's see first the meaning of that. So this is given as bacteria count CFU per ml. So as per a quick Google search, you can see it stands for colony forming units per milliliter, a unit used in microbiology to measure the number of viable or live bacteria or fungi in a liquid sample. So here we can keep the average bacteria count in CFU per ml. So we will use average value here, which is 2.49 K throughout the rows that is given here. So this will be the average of bacteria count in CFU per ml, which is 2.49 K. So in the context of urine cultures it is given, although you may have to do more research here. But if the value is less than 10,000 CFU per ml, is generally considered normal. So what you can see, like in all the countries in different regions, you can see if the values are particularly higher in any particular region. Country wise also you can try to analyze where it is higher than usual, and that way you will be able to analyze, right? So this is bacteria count, and similarly when you are analyzing these kind of values, you can also see what is the normal range, right? What is the upper range, lower range, normal range. This type of analysis can also be done by doing some research using Google or any chat GPT or any other type of uh, you know in any other type of chatbot that can help you, like Copilot, etc. Now we also have the contaminant level in ppm. So just like we did this, we can also see average contaminant level in ppm For that we will simply drag it here, and here we will select average, and you can also do some research like how much average value in terms of parts per million is considered normal, and you can see in which country, which region it is higher or lower. Here in filters we will try to create more filters like year also, because you have to, if you have to do yearly analysis, that will be very important. So we can put year. We can also put water source type here, and we also have the water treatment method. So you can see with that water treatment method, if the average of contaminant level is going up, average of bacterial count is going up or down. So we will put the water treatment method here, like in case of filtration, boiling, chlorination, right? So you can see these values, and you can see typhoid cases based on these type of treatment method, whether they are going up or down. So now we have these different filters here, and next is diarrheal cases, which we will do in the next dashboard. We also have the dissolved oxygen in milligram per liter. So here we have the dissolved oxygen value. We will also take its average value here. This is average of dissolved oxygen. So I will copy the title from here and put it here. So this way we have created some KPIs that will help us in analyzing the effect of these different type of parameters on the water diseases, in this case typhoid cases. And as we have created average dissolve, they have given some other values like GDP per capita in USD. We have healthcare access index, infant mortality rate. So since we are analyzing different type of water pollutants here, so we can also see lead concentration in microgram per liter maybe it is given. So we will add lead concentration and select their average. Based on similar kind of procedure, you can also create another row here where you can put other type of parameters. Other type of parameters can be something like healthcare access index, the infant mortality rate, the GDP per capita, right? We also can put population density. So these are not related to water disease, or these are not related to water concentration, but something else. But you can consider these factors also, like urbanization rate. Now what we can do here, for example, we have GDP per capita. So let's say if GDP per capita increases or decreases, will that increase or decrease typhoid cases? So here we have information of GDP per capita in terms of USD. So first let's see the GDP per capita column, something that we can do here. So it is given like this. You can see the minimum value is given as 521 and maximum value is given as 33,207. It can be value of different years. So first thing that we can do, because the range is too high and there are so many values, so first I will try to create some group of it. So I will create a new group. Here the GDP bin size is $3428. I will say I will do it as per number of bins, and let's say we want to do number of bins as 25, which will give us bin size of around $4,000. Let's click OK. Once you have this group, what you can do, you can create a distribution. So first we will create a bar chart here, and in the bar chart we will try to create a distribution, a simple histogram plot kind of data here. So we will put it on x-axis, and on y-axis we will put number of cases. So if we are trying to analyze, for example, typhoid cases, we can do this thing here, like typhoid cases we can bring here. This is some of typhoid cases per 100,000 people, which you can see here that in these are different GDP ranges, right? For example, here in this range, number of cases are higher, here they are lower. So it will kind of give you the what kind of effect does GDP per capita USD has on typhoid cases. Similarly, you can find it for other cases also, like for example, if you have to do it for cholera cases also. So we can try to bring it, and if you want to analyze them in parallel, what you can do, you can use a clustered chart instead of a stacked. So you can see number of cholera cases. So which I said I will do it in another part, but I'm just giving an example here. What we can do, we can use format painter to apply the same kind of styling here, and this way we can see effect of a continuous numerical value, which is GDP per capita here, on our target variable, which is typhoid cases per thousand people, 100,000 people. Similarly, we can create another chart here. So we also have healthcare access index 0 to 100. So here, as per some quick research, you can see the HAQ index provides a more comprehensive measure that reflects health system capacity. So for different countries, it will be a different thing. So first thing that we will try to do here, as we created a group, so for this also we will try to create a group healthcare access index 0 to 100. So here we will click on these three dots, because first I want to show if we don't create a group what will happen. So we just have to replace this with this value. So you can see we will have around 100 values here, right? We may have around 100 values here, and it will be very hard to analyze. That's why we group these in bins. So we will create a new group. Here the bin size is 3.44. I will say number of bins, and I will say let's have 15 bins. So every bin size will be index value from 0 to 6.65, then 6.65 to 13 or something like that. So when you will do that, now just replace it with the healthcare access index, and this way you will be able to see number of cases on the basis of healthcare index. Similarly, I have created 15 bins of urbanization rate, and here I will bring this also on x-axis. So urbanization rate group on x-axis. So we can put these parameters here and try to see their effect on what we are considering here, our target field, the typhoid cases, and the parameter that we are using is sum of typhoid cases. You can also select average value, you can also select minimum or maximum value, so it's your choice, but here we are seeing total number of cases, and you can do year wise analysis as well. So the important thing to understand here is that on x-axis we have urbanization rate. This is some group of urbanization rate. If you will go to edit groups, you will see the bin size is 5.33. So urbanization rate between 0 to 5, etc. Let's say we want to go with size of bin and we keep the bin size 5. So 0 to 5%, 5 to 10%, and so on, like urbanization rate. First of all, number of cases here you can see in the urbanization bin of 45% are higher. This is one thing. Next, if you want to use any other chart, for example, ribbon chart here, it will also give us the same kind of indication, right? Just as a envelope kind of thing. But here in legend, we can bring some categorical value also. For example, we have different water source type, we have different regions, or we have water treatment, uh, you know, method. So let's say if you want to see water treatment method wise and urbanization rate wise, what is the effect on typhoid cases per 100,000 people, so, what will be the value, higher, lower. So category wise, if you want to compare them, then you can use this ribbon chart, and in legend you can use that value. So for example, we can use the water treatment. So here we have the water treatment method. So instead of sum of typhoid cases, we will simply use typhoid cases per 100,000 people, just to keep it simple. And here when you will expand this, you will see, like for example, in case of chlorination, when the water treatment method is chlorination and the bin size is 45%, so for chlorination this is the highest in this particular bin, right? And you can see rank of different type of these categories in different urbanization rate bins on the basis of water treatment method, which is given here. So this is also the same kind of distribution, but here you can also try to understand rank of each category in each case. If instead of this we use a simple stack chart, then also we will see something similar, but here we will not be able to see rank. We on the basis of value you can see, but it will be difficult to identify the rank. But here, in case of a ribbon chart, it will be easier. So this is the difference between a stacked bar and a ribbon chart here. And as we have done it in this row, we can do it for other parameters like for sanitization coverage percentage of population, temperature wise, turbidity wise. So these type of things can also be done, although because we are just trying to teach how to do it, students can take this as a simple reference, and they can do it on your own, they can do it on their own as well. They can create more dashboards here with more visuals. Now I want to do one more thing. For example, we have rainfall and temperature, let's say. So so in case of rainfall, we have values from 200 to somewhere around 1600, etc. So let's try one thing here. As we created the groups earlier, so I will also create groups this time for rainfall. So here we have the rainfall in millimeter per year it is given. So we will create new group. So here the bin size is 96, like in terms of mm. I will just go with number of bins, and although we can go with values from range, we can create like if it is between 0 to 500 low, 500 to 1000, you know medium, some kind of that value. So I will just go with 4 bins. I'm just showing one thing here. So it can be low, medium, good, very good, something like that. This will be the bin count. So now we have this rainfall value. So now it can be used as a category also. Earlier we used it as a, used it on x-axis as a continuous value. But here we can use it as a category also. So let's say we create a simple donut chart here. And in the donut chart, we will try to see on the basis of rainfall what will be the number of typhoid cases. So in legend I will bring rainfall, like whether this is help affecting. So you can see rainfall bins 200, 899, 1599 and 2299. Four bins are created. So rainfall range is now, you know, divided into four groups, and here we will bring typhoid cases. So this is also one way we can use. And here you can see, as per the data, 26.75% of cases are in less rainfall, and this is highest rainfall. So 24.82% cases are in higher rainfall, and so on. So as per the data set, this is what we can see here. And you can try to create more groups. You can try to create a calculated column with more specific values, like if it is between 0 to 300 very low, 300 to 600 low, 600 to 900 medium, something like that. So you can use the switch function. So this is something you can do as well. Now we can use the format painter and we can see sum of typhoid cases by rainfall in per year, and it will show as bins. If you want, you can rename it from here and replace bins from here. And we can do it for different cases like region, we can do it for water source type, we can do it for water treatment, etc. So let's simply create a copy of it and try to analyze it like this. So here I will just use water source type. So if we have a in what type of water source type we have more number of cases. So as per the data set, you can see if the water source type is a spring, we have around 18% cases. Then we have river, around 17.86% cases. So, and lowest is 15.5 percentage of cases, which is a pond. So this is also indication, and here we can select just pie chart, which will be the same thing with same color scheme. And similarly we can see for different regions also. So we can use a simple tree map here. In tree map we can put a categorical field in category. So we can put region here. We can also put country information here. For example, we have different countries. So if you want to show country wise number of cases, and then we have details and values. So in case of details we will put the typhoid cases, right? So we have the typhoid cases which we will put in details, and we will put them in values as well. Let's remove details for now. So now you can see we have Brazil here, and we can go to data labels and enable them, so we can see the values also. And now I will simply copy the styling from here using format painter so that we can copy the title here. So this is sum of typhoid cases per 100,000 people by country, and as per the data set this will be ranked. So in Brazil most number of cases, then USA, then Indonesia, then China, Nigeria, etc. And this is as per the data set, the sample collected in the data set. Now as we have created this simple exploratory analysis dashboard for typhoid cases, we can also copy the dashboard and just replace the value for cholera cases or diarrhea cases, etc. We can create more dashboards in case of typhoid, cholera and diarrhea, etc. combined, and try to put more features here. So this is just a simple beginning of this project, and this is the first part where we have explained how to, you know, begin with the analysis of such kind of things. And in other examples you will see more detailed analysis. So please subscribe to our channel to receive regular notifications. We post Power BI and data analysis related video tutorials regularly. So whenever we will post a video, you will get a notification, and it will help you whether you are a professional or a learning, or you are just learning as a student. All of these things will help you in better understanding of these concepts, exploratory analysis, how to begin things. So please do it. Thanks for watching this video. Have a nice day.